This is the Makera Z1 CNC machine. It's not a 3D printer, it's not a 3D scanner, it's a CNC machine. And on paper, it looks freaking awesome. So let's get it out of the box, fire it up, and see if we can get some chips flying all over the studio. I'm super excited about this one. So I ordered this myself at Kickstarter, and I'm actually backer 148, so I got this real early. I actually opted for the non-pro version. It had some beefier bearings and lead screws. I'm not sure I'm gonna need it, but if I do, at least the Kickstarter versions can be upgraded. I did, however, opt in for a lot of different accessories. For example, the fourth axis. First up, some documentation. It's time to lower this machine down so we can pick it up. Let's see, how are you supposed to lift this? I have no clue. Let's get some accessory up first. These are spoil boards, MDF spoil boards. Let's get some of the more packaging out. Ooh, what is this? Essential milling bit kit. Nice. Are there some handles on this machine? I don't think there are. I think that's the rest of the box. Empty. Oh yeah, it's pretty small. Look at that. Ha! Isn't that nice? Ooh. We have a lot of stuff down back here. Vacuuming, I think. Cheap evacuation, airflow, something. 3 things here. That looks interesting. Power. Exciting. So what is inside? That's the on-off button. Woo! Wow, there's so much in here. More packaging. Ooh, I can feel the static electricity. I know one of the things that they added was like this static probing thing. So much stuff. We have the vise. And we have more stuff. We have clamps. No? Adapters. We have... Oh! More gifts! More gifts! There's so much to look at there. Jesus Christ, even more! And I think that's it. So there it is, out of the box. Let's take some close-ups so you can see all the details here. Let's see what we actually got for accessories. This is a low profile vise. It looks like you kind of have to build it yourself. Ooh. I have to learn how to use all this. This is the fourth axis rotationary module. Ooh. This means I can spin stuff around. So, oh, cool. So we get some practice blocks. Something to try out. Oh, this is nice. Wow, that is quality. Some screws, cable. This is gonna be awesome. This really feels like high quality. 2 flute engraving bit, 0.6 millimeter, 0.3. Look at that. Oh, that's so beautiful. What's next? What's next? Oh, accessories and materials. We have the 3D wired probe, and this is a wired probe. We have some double 2-sided tape, power cable, we're gonna need that. Spindle collet, 6 millimeter. I think we have another one. Spindle collar, 8-inch. Lubricant, grease and oil. Bits adapter, 6 millimeter to 3.8. We have another bits adapter, a sanding block. cable, USB-C to USB-A. Nice. We have safety goggles. We have a stop button. We have a safety switch. That's cool. We got some extra material as well. We have the MDF spoil boards. I think those are pretty obvious what they are. There's already one attached, so these are extra ones for when you mess up, which this guy is gonna do. 26 essential milling bits kit. Yes. Holy crap, we have so many bits. So many bits. And we even have one more bag of accessories. And then we also have another box coming with even more accessories. Dude, we're gonna be dialed. So we have a Black Friday gift from the Kickstarter. So in here we have more bits. Kickstarter 24-hour gift. I have no clue. Oh, more bits. I'm gonna have to make an Excel sheet just to keep track of all of these bits. This was stretch goal, 6mm spindle collet, and bits adapters. Very nice. Black Friday gift. A clamp. Another clamp. Stretch goal again. This is 3D probe. Okay. We have wired probes. I'm not entirely sure, but we have a lot of probes. Ooh, there's another Black Friday gift. A thick L bracket. Lastly, in this shipment, we have Black Friday gift. 2 more clamps. I guess the only thing next to do is to try and find a manual and then get some software so we can have a look at how do we even set things up. Because the goal now is to make some chips, maybe from the stock materials, maybe from the wooden one. So let's see what we can do. I quickly checked the manual, and the first problem that I found was software. At this stage, the official Makera Studio software is not released. But I was told that Makera CAM and controller apps could be used. So I got those from Makera and installed. Next, I needed to connect the machine, and I tried a lot of different things and apparently didn't find the right USB drivers that were communicated somewhere. But finally, I got through using the Wi-Fi from the machine itself. So we're connected and I can actually jog the machine. I didn't want my first attempt to be anything important at all. I even estimated I would break a bit or two trying to do it. So I just took a 2x2 and cut it off a piece around 50mm tall. I loaded it up using the L bracket and then a side clamp. Felt really rigid. Then quickly drew up a super simple shape in CAD just to get it into Makera CAM. Again, this is not a tutorial. I struggled finding a toolpath that would work, but I tried a few different options. And then I thought that I had something. So it looks good. So next up, how do I run it? After some struggles, I realized that I have to upload and select G-code on the machine. So when you try to run code, you have these offsets. So the blue one is the origin of the work that you're trying to do, and the green is the area that you will cut inside, and red is where it will probe, or yellow if you're doing auto leveling. So for me, I try to find like offset to get it into the L corner, because that's where my piece is. So I tried here several times and finally kind of figured it out. And I thought it was smart to use the auto leveling. So, and then with one finger on the on-off button, I click run. And to my surprise, the first thing that came up was a prompt, put in the probe. So I did that. Clicked OK again and let the machine do its magic. So first it's homing the probe. You can see the probe go down to this homing thingy in the right corner of the build plate. And then it will draw the area of the workpiece. You can see it kind of fits, it works. It's not perfect, but it indicates that things are as they should be. Next up, it does an auto leveling pattern. I guess you don't need to do this always, but it's very nice to have for when you do. And after probing, the machine actually tells us to put in the next tool. So that's what we'll do. We'll unload the probe, put in the correct tool. In this case, I think it's a 2mm ball nose bit. And then when we click confirm, the machine will actually move into place and start cutting. This is so nervous. In the top left you can actually see the camera. I'll show you some clips from that later. It actually saves the cuts or the machines like a time lapse on the SD card. But we're off and we're cutting. I'm probably doing this way too slow. I have no clue about the settings in Makera Cam. But I wanted to be restrictive. You can see everything's working. You have this live view from the Wi-Fi and the cam controller. And you can actually put like a speed, like a percentage speed on some of those buttons there. So I tried that a little bit later and it went faster, but it was still like a 2-hour milling operation that was way too conservative. I think maybe the preset is like aluminium or steel or something. Way too slow. And when everything's done, we unload the piece. Definitely not perfect, but it's my first piece. This is not something complicated, but I thought it was pretty fun to do some 3D shapes. So this was one toolpath, one tool, fairly easy to do. Now I want to do something a bit more complicated. So let's go into Fusion 360 and just make a test project, some cool patterns. So one thing I'm learning about Fusion 360 is that it's not fully compatible with tool changes. It doesn't look like it. There is a Makera post-processor, but it's not officially the one for the C1. So for my setup, I'm using Makera Cavera machine. Like this is the setup. It's an important machine I think it's an official machine or from the profiles from Makera. And then I designed my like test piece here just to see like if we can do complicated curves. Then I started to add these different toolpaths, mostly 2D and 3D toolpaths. You can see the naming there. It's T1 is tool 1, T2 tool 2, and T3 tool 3. So I wanted to try different toolpaths with different tools. I'm not sure anything here is correct, and I'm already struggling a little bit thinking 3D printing when we're actually cutting. So a few of the radiuses and the different shapes of these test objects are, like, for me, really difficult to get correct. You can see in the preview on the stock milling here that I'm not really cutting into the shapes that I want to. I don't have time to struggle with that now, but it's a learning curve, and I think it's a cool one, it's a fun one, but I'm really not there yet. And then we have everything from feeds and speeds that I'm just using like softwood or hardwood templates for now. Then we have everything about tool holding and fixtures. Oh, that's gonna be a different topic for a different video. This Fusion project, let's see if we can actually get it going on the machine. So the first thing we need to do is to prepare the mounting of the new piece. I'm gonna use one of these pieces to try and machine out this test. And also, if you don't have the paid version of Fusion 360, like the manufacturing edition, it doesn't look like you can export one file with manual tool changes. Or maybe you can, maybe I don't understand it. So I'm a bit curious because I had to export like 4 files for the 4 different tool swaps that I'm going to do. And I have no clue if they're going to be in the correct space. So this is going to be exciting. But first, let's load this up and then see if we can get some chips flying. So first thing, we unload this. I don't think I'm going to use the side clamp. Let's load the piece. One top clamp. It needs to be here. That should be good. Okay. So I have uploaded and selected my code. The offset looks good. I'm gonna remember that for later. I actually took a picture of it in case it didn't work across programs. So then let's run it. Of course, we have to probe this plate as well, like with the other things. Switch in the first tool, tool 1, and we're off to cut. For the next operation, I think I'm pretty smart because I moved the area of the C probe. So you can see the red dot is now outside the work area because we still have our stock there, so I can measure the C height from that. So now it's the ball tool head. And then I'm loading up one of the chamfer programs. So you can see it uploads to machine. This is super simple, it's just a chamfering bit. It just does the chamfer around the outside of the parts here, of the circles. And then I tried to cut it out using like the cutting program. I actually had to do several offsets here because the first one didn't cut the piece loose. So I actually reduced the bottom height a lot to get through the part. I actually didn't measure the part, I just assumed it was 10 millimeters, but maybe it was 12. So there you can see it cut it loose. And after some vacuuming, we have a finished piece. I think it looks beautiful. Really nice quality, really smooth surfaces. Okay, so milling this piece out was way more complicated than I thought, but it was a really good learning curve. I think I have a pretty good idea about what I need to do. I need to measure the stock better, but things are working quite well from Fusion 360 to the Makera, even without the Makera Studio software. And actually, as I'm filming this outro, I just got approved for the beta program of the Makera Studio, so I'll be trying that out later. For now, these are the two pieces we managed to make. This one looks super nice on the finish, and this one is of course very rough. It's just the first cut test piece. So we have a lot of material here. I have some aluminium plates as well that I want to try out, and I'm going to need to buy some stocks. But that is for the next videos. And in there I will also try out the new software and see if it's actually working. But for now, this delivers really well. I mean, the precision, the details of this small part, actually quite amazing when you look at it. There's some finishing I need to do on the edge here. There's a lot to learn, but I think this is super cool. I'm really excited to see what I can make. And I must say, I'm really surprised by Fusion 360. Even the free version works really well with the 3-axis. I'm not sure if the 4th axis is going to work in there. We'll try Makera Studio for that. But the way you work with different types of operations and the different tools that you use, I think it actually works pretty well. Even if I can't put everything into one file and have automatic tool changes, and I was actually surprised how well Camera Cam keeps track on the offsets that you want to do. So for all of these programs, I think it was 5 or 6 or even 7 because I needed to keep increasing the down cut so I cut through. All of those programs loaded very easily into the Makera controller, and it kept all the offsets that I wanted to use. So I probed the C height every time, but all the offsets from the anchoring made that all different programs were able to run in the same position. So I suggest you like this video, you subscribe, and you make sure you let me know what kind of stuff you want to see cut on a CNC machine. Are you thinking about getting one? Check out the link down below. Maybe I have some discount codes. I have no clue, but I'm not sponsored by Makera. I bought this for my own money, but I do have affiliate links, I think, for Makera. So if you want to check those out, everything is down below. You can see the price of the machine, all the tools, and everything you might need to get started. See you guys in the next video. Thank you so much for watching this one, and make sure you let me know what I missed and all the stupid mistakes that I did that you wouldn't do. I know there's a lot of experts out there, but for me, making tool paths is completely different from making designs that you 3D print. I think that's my biggest lesson here. Things that work with 3D printing are not as easy to cut, but on the other hand, things I can do with this one is solid and strong in all axes. So that's going to be pretty exciting. Thank you so much for watching. See you guys in the next one. Bye.